Our fourth topic is remainder theorem and synergetic division, which also known as Horner's method. With this theorem, we can identify is there any remainder in the polynomial or not. So let's begin with an easy example as here. In remainder theorem, we use an unusual method of solving. Uh, the first we equal to x to 0 and the x will be equal to 1. The you should find every digit in every part of polynomial. Here's the 1, 3, and 2. And second is right, so there is a 2, 1, and 0 degree. So everything inside is right. Let's begin. Our first step is 1, the first digit number, multiply by 1, and plus 3, which will be equal to 4. Second is 4 increased by 1 plus 2. The answer will be 6. And in this polynomial, there are 6 remainder. Now let's solve the second one. This last time, find the 1, and there is a problem with the sequence of degree. There is not any number of 3x x cubed, so there's a 0, 4, minus 3, and 7, and it is equal to 2. First step is the 1 equal 1 plus 0. 2. Second step is a 2 increase multiplied by 2 plus 4 is equal to 8. Third step is the 8 multiplied by 2 minus 3 is 13. And the last is 13 increased by 2 and minus 7 or plus 7. Answer is 33. And there is a 33 remainder. Let's begin to solve a question of the Horner's method. And the first step, you should identify is there any problem with the sequence of degree in each polynomial part. 5, 4, there should be 3. So each insert degree there is 0. 2, this there is no also first degree, so there is also 0, and 12. 1 minus 3, 0, 4, 0, minus 12. There is a plus, so x is equal to minus 1. 1 multiplied by minus 1 minus 3 is 4. I mean minus 4. Second step, minus 4 multiplied by minus 1 plus 0. It will be 4. 4 multiplied by minus 1 plus 4 is 0. 0 multiplied by minus 1 plus 0 is equal to 0, and 0 multiplied by minus 1 minus 12 is minus 12. So the answer is there is a minus 12 remainder. And last topic, which related to polynomial, is solving higher degree equations reducible to quadratic equations. His name says that reducible to quadratic equation, so uh, it's similar to factorization, but we solve the factorization and it's the same way, but first you should find the object of replacing. So there is a x quadrant, we can replace it to any vector, for example t. So t quadrant minus 5t plus 4 minus 4 minus 1, t equal to 4 and 1. So the path is not an answer, so you bring it into and replace it by t. So x quadrant equal to 4 is plus or minus 2, x quadrant equal to 1 is equal to plus or minus 1. It's the same approach of solving each equation, but with different uh, higher numbers. The same way, x quadrant is equal to t quadrant minus 13t minus 30. We break into minus 15 and the plus 2. So t equal to 15 and second is equal to minus 2. X1 is equal to plus or minus 15 under degree, and second is equal to second is undefined, I guess, because how an answer can be minus from quadrant. So this is identified like identified. The last problem is similar, like O and 2 quadrant minus 10t plus 9 equal to 0, minus 9 minus 1, t equal to 9 and 1, and x is equal to plus or minus 3, and second root is equal to plus or minus 1.